have 20 minutes for the talk, right? Timer. Okay, and I'll have to stay nearby the microphone. Okay. I'm constrained in my movement. Well, so I'm going to be talking about web-based data analytics with F#, and I'll start with a rant. One of the sort of comments I got from the reviewers of the work was that they've seen shiny demos of F# before, and they want to see some substance. So I will actually give you some substance at the end, or there will be something sort of looking at the individual features. But what I'm really trying to do here is more of a show you how the things work together by giving you one sort of example that's you can think of it as an experiment. And the rant here actually has sort of philosophical base to it. There's this movement in philosophy of science called new experimentalism, where they say experiments can have life of its own. So if you look at something like motor, it's a thing that when you run it, it will start moving, and it doesn't depend on what is your theory, whether you believe in electromagnetism or in something else. So I think in sort of programming languages research or in computer science, we can also build things that you can run them and they do something interesting, and you can maybe sort of look at how it's written without really sort of looking at all the fundamental pieces that make it work together. So you can see that there's something interesting happening, and maybe you don't really need to know why to see that there's something interesting happening. So my aim here is sort of to give you something that's looking at something that's non-trivial, real-world-like problem. So hopefully it's going to be an interesting case study that shows you can build something interesting, and you can sort of value see the value of the application even without actually looking at the programming language. But I'm going to be using F#, and I think that lots of the things you will see in the demo are actually following from the nice ML tradition. So that's my sort of introductory rant, telling you that I will still show you a shiny F# demo, which is what I'm going to do next. So how many people here have already seen some demos on type providers in F#? Some of you?
All of the ones I've seen were by you.
That's because I hate. No, I don't actually. So what I'm doing here, and this is just to show you a demo which will be running in my editor, and this is using something that's called the World Bank type provider, and it's a type provider that's accessing data from the World Bank, which is an international organization, and that it collects different indicators about different countries. So here, there's this World Bank data thing, this type here. That's not actually a type in a library. It's something that's generated by a type provider, which is one of the libraries referenced on the first line, and it happens behind the scenes when I reference the library and the compiler looks at the types. It actually invokes some code, and the code will determine what types I get here, or in this case, what properties or fields are on this type called countries. So here it's giving me all the countries in the world, and there's some interesting things happening because this is giving me the countries that are in the world today. So for example, Scotland isn't there yet. Sweden is there. I can get indicators, and going to look at how many people go to university in Sweden. So you can see again, I got the list of all the indicators there. And if I run all my code properly, then you will see a chart showing the change. So this is the part of using type providers. I will get back to it later, and I'll talk about what this means for the type safety, because obviously that's the interesting, fun question here. But I want to show you some other things. So this is going to be putting together multiple pieces of work that's been done around F#. Type providers will be one of those things. This is just Microsoft telling me that I'm loading type providers. It could harm my computer. I don't care. And the thing I want to do here is that I want to write a web application where you will be able to compare different data for different countries. And to do that, to do any client-side web application, I will obviously use F#. And as part of that, I need to have some way of calling JavaScript. I want to use standard JavaScript libraries to do like alerts and use some fancy user interface features. And here, I'm going to be using type providers again, but for a completely different purpose than for accessing data. So what I'm doing here is that I'm using these so-called TypeScript definitions, which is some way of annotating JavaScript libraries with type annotations. It's not coming from the F# world. I don't really care about it that much, but we have a type provider that gives me a type called lib that's sort of representing all the types that come from that type annotation. I could even show you what this looks like, but it's really just a file which tells me these are all the functions that are in JavaScript, and this is roughly how they look. So this will import that sort of from that ugly world into the nice ML type system world. And now I can do lib dot and see all the members like window and alert. I can say hi. And this is really just writing a call. Can make the font a little bigger. And I can also run this. And when I run it, this is another interesting thing. It is actually translating the F# code I wrote to JavaScript. So when I run it, it will start some console application that hosts the JavaScript, but there's no F# code running in this demo. It's all running in the web browser as JavaScript. And there's some template for a page, which I'll do a few more things now. So this whole thing, the code I'm writing here, that's actually translated from F# to JavaScript. And I can write fairly complicated stuff here. So what I'm going to do is that instead of using just the plain JavaScript DOM model, I'm actually going to be using jQuery and a library called highcharts. So I'll just import those libraries into my sort of ML type system. And I will actually also use the World Bank to access some data. And I just specified additional attribute here saying the data access should be asynchronous. And you'll see later on what this does. And this is just sort of hard-coded list of countries here, where I picked some countries that I will show on the page, and you'll be able to select different countries. And now that we've got the setup, I'll add a little bit of code, this is just sort of fairly standard JavaScript-like programming, except it's done in a more type-safe F# land. So here we take all the countries, and I'm using this imported jQuery library to do things like set the attribute on an input, so you get sort of type-safe or typed access to all the library features. If I run it again, then it will generate the checkboxes with the different countries. So the last bit I need to do is to add some interaction where if I click on a checkbox, it will update the chart. So I'm going to write a function called render, and what this will do is that it will, oh, it's already here. It will need to create the chart. So I have this type, again, imported type representing the charting library. I'm going to do some initialization to set up the charting, and then I want to iterate over all the checkboxes that I created in my infos. And if the checkbox is checked, again, this is imported from jQuery, and you can see all sorts of jQuery things in the type annotations. So if this is checked, and in jQuery you don't have that much type safety, so when it gets imported to the F# world, you can't really sort of get fully type safe view. So in some places I need to do unsafe coercion and say, well, I know this is going to return Boolean. So if it's checked, then I can get the data from the World Bank. So for the country, I will get the indicator that I care about, and that's university enrollment. Now, there's one other interesting thing happening here, because we will be running this in JavaScript, and in JavaScript, you can't make synchronous calls to web services. You can't say, call this service and block the browser window until we get back the data. And that's why initially I put this asynchronous parameter on my World Bank service. And what it's returning here is the F# async type. So it actually gives me an asynchronous computation. And in normal F# code, I could just write async, curly brackets around the piece of code, and use letbank here to say, actually, I need to do this whole computation asynchronously. And it turns out that in this F# code translated to JavaScript, I actually have to do exactly the same thing. So that's another sort of interesting aspect playing here, where I don't really, I can use asynchronous workflows inside the program that's going to be translated to JavaScript. And I think the last bit of code that I need here is just to say, when I click on a button, re-render the window. So if I run it, assuming I did everything correctly, and we can select, there's Denmark. So this is how the school enrollment in Denmark has been changing. We can add United States. There's also some aggregates like low-income countries, or we can add European Union average. So again, this whole thing is running in the web browser as JavaScript. There's no F# runtime. It's all translated to JavaScript, but we have actually used quite a lot of F# features and ML sort of family features throughout the process. So what's actually happening here? Well, we've used the type providers for getting the data and for interoperating. We've used some F# metaprogramming for translating the F# code I wrote to JavaScript, and we have used these asynchronous workflows for turning the synchronous code that would be blocking into non-blocking code that can perform web requests. The metaprogramming part, I think that's definitely something that can be done in lots of other languages. The feature that's interesting in F# is that it picks one fairly narrow area, which is heterogeneous execution. So the idea is we'll write F# code and then we'll have some way of taking that as an expression tree and translating it. But it's not full sort of macro system. It really focuses on just this narrow problem. When we combine that with the JavaScript translation, there's lots of interesting problems, whether you want to sort of keep the F# semantics or adopt some of the JavaScript semantics. And the same problem with libraries, like do we want to be able to run any F# library in web browser, or do we rather import JavaScript libraries? And here F#, on the library side, the library I was using to do the translation, that's actually more trying to import the JavaScript libraries. It gives you some basic F# functions, and you can use them in the JavaScript context. But I think that's actually one really interesting alternative to, I think, what some of the people in the Haskell community are doing, where they basically say, you will be allowed to use any Haskell library, but you have no good interrupt story. So there's these two choices, where F# in this demo is actually staying more on the import JavaScript libraries side. With the language semantics, that's again, it's really, really hard to replicate any sensible language semantics in JavaScript. Because in JavaScript, even the numbers are different. If you fully wanted to keep the F# semantics in JavaScript, you would basically have to re-implement the whole .NET runtime. And this is something you might be able to do maybe for GHC, where you really know the full runtime. Again, here, F# is trying to keep the reasonable, or the core parts of the F# semantics that you really need to program anything. But when it comes to things like exceptions, it's, again, more on the side of importing what's there in JavaScript. The asynchronous workflows part, that's the async block, that's actually suffering from the same problem, where, again, in JavaScript, we just have a single thread, and the asynchronous workflows in normal F# are generally designed to be multi-threaded or run using multiple threads. There is actually one part of the F# programming model where it lets you program with just single UI thread. So when we are translating to JavaScript, we actually take that part of the, we only allow you to write code that in the normal F# would look like you're running on a single UI thread. It still slightly changes the semantics, because blocking in the well, JavaScript doesn't really let you block, but if you did some infinite loop, then that would behave differently than in the F# world. So again, we are slightly changing the semantics, but the basic sort of principles of the programming model that you get are staying the same. The other thing here with the async workflows, which I find really important, is that I could just write my code in normal F#, and then when I realized, oh, now I actually need to do a web request call, I could just add the block around it, wrap it in the async curly brackets, and it would work. And that's because inside the async curly bracket block, which is kind of like the do notation in Haskell, I am actually allowed to use most of the standard F# syntax, like for loop. So having a nice syntax for these sort of additional features, I think, is really important. I already showed you everything about type providers. I think there's sort of interesting big picture story here, where I was using the same mechanism for getting data, for data access, on one side, and also for language integration or for interoperability. To conclude, I think the ML type system that is sort of in F# really has its value. It's just slightly different in the context where I was using it, because it helped me all the time when writing the code, and I would never ever be able to do any of the data access stuff without nice type inference. there are still some safety guarantees that you get from this. But obviously, when I import my countries into the type system, when the world changes and Scotland splits, my program, well, splitting is fine actually. Splitting is okay because it will just be new country. But if someone mentioned if Czech Republic decides to join back with Slovakia and they will disappear, that will make the program break. But that's actually a good thing, because the idea that well-typed programs don't go wrong, that only means well-typed programs don't go wrong for errors that are tracked by your type system. If your type system isn't tracking something, your program may still fail. And here, we are tracking more things, but we are tracking things that change with time. So my program will give me a type error, but that's actually good because I will at least know earlier, I will at least know when I recompile my program that there's something wrong. And it would eventually crash at runtime. All right, I'm going to skip this and I'll just say a few closing words. I think it's really interesting to not just look at sort of small language features in isolation, but try to do something that's putting more of them together. And I believe in this case you get that 1 + 1 is more than 2, because I think I got it the wrong way around. Yeah, I don't know how to do greater than equals. It's using PowerPoint. So 1 + 1 is more than 2, and all the features that I was using are actually quite orthogonal. And the final note there is, I think, type safety, if we sort of want to use it to the extreme, then it becomes more relative, but it's still useful, and the ML type system features are really fundamental for doing this kind of demo. Thanks.
Questions?
I have a kind of general question about like the more integrated aspect of language design that you described, which is, in which direction do you decide you'll improve your language? Like, you've shown nice things of F# that look very interesting for some kind of applications, but maybe less for some others. So there is a kind of complexity deal, and I'm sure you have users that are interested in this particular kind of application. But as a kind of neutral, or maybe not a neutral, language designer, how do you decide in which direction you're interested in? Like more crazy live coding, or financial type of something?
Yeah, I think that's really interesting question. I don't think I have any good answer really. I think the nice aspect of most of the features that I was showing here is that they are fairly minimal syntactic extensions. So the type providers, for example, you need like a little bit of syntax to say in angle brackets some arguments. But otherwise, it's mostly a library feature. Well, it's changing the language, but without sort of making the syntax significantly more complicated. The async workflows, again, like you wrap some syntax in a block, so you have to add the block, but you're still delegating most of the features to the library. So I think that the nice thing here is that we didn't actually have to add that much to the sort of visible language. How do you choose the features? Well, most of these came from like some number of practical motivations coming from the F# ecosystem, which is definitely one source, and it seemed to be working pretty reasonably well for F#, but I don't think that's a general rule. I find it much easier to sort of see how the language could look if I had one or, well, a number of related problems.
your data sources and type provider, do you have some kind of version constraints?
Do I have version constraints on the type provider data sources? So I can only do sort of as much as the data source gives me. If the data source was some nice structured service that has a version, and I can say, give me data. Like there's this functional database where you can basically version. Every time you mutate your database, you're actually creating a new version. And then you can say, I want to program against that specific version, and then it would be a really nice thing to integrate into the type provider, because you would know, you would have guarantees. You would sort of, because the data source gives you guarantees, you would get the guarantees in the language. Most of the samples I was using here, like the World Bank, they don't have any versioning, so I can't sort of impose more on them than they actually have.
So you showed two different kinds of metaprogramming, the heterogeneous compilation and type providers. And are those related inside F#? And can you talk about their relationship?
Yeah. So yes, that's a very good point, because both the translation to JavaScript and the generation of types are a form of metaprogramming. And I think here sort of F# is picking two narrow, interesting directions that it thinks are worthwhile and doing these. Under the cover, if you're implementing a type provider, then you would use the same sort of data representation for expression trees for generating the code that's actually executed. So they are technically related. I don't think that's sort of fundamental aspect there. It's sometimes useful, but I've never actually sort of had to write the same code for both problems.
So it sounds like one is a consumer and one is a producer of this expression tree data type. And the idea of a real representation of expression trees is the key idea between them.
Yes, yes. The fact that they both sort of need to use expression trees is the key there.